Hello everyone! I thought I would do a quick little thing on the scientific method, but of course, since I'm the one doing it, it's going to be a little bit more than just the scientific method. But first, what is the scientific method? Well, the scientific method can be described as follows. First, observe something. So you have to be paying attention to things around you. You perceive things. And then what do? You don't just observe, you think about it. And when you're thinking about it, you come up with ideas. That's the same thing as formulating a hypothesis. You come up with an idea of why something is the way it is, or what happens if you do a certain action, what will be the result, things like that. After that, you do an experiment to test your hypothesis. So you've thought about it, and you thought, I think if I do this, that will result. And then you do an experiment to test the hypothesis. Then you observe the results. And that will lead you back really into the loop that we're doing here. You observe, you think about and come up with an idea, you formulate a hypothesis, you test, and you experiment, and you observe the results, and then you draw conclusions from those experiments. This, roughly speaking, is the scientific method. Now, there's more to it if you want to be a published scientific author, for example. You'll have to actually publish your research, things like that. I'm not going to go into that here because this is just talking about the scientific method as an idea, a concept, not as a way of making money or getting grants or things like that. One thing that must be dealt with is the idea of falsification here. If a rightly designed and conducted experiment proves a hypothesis wrong, then we know it's wrong. That is, we have falsified it. We've proven it to be false. But the flip side of that is no experiment can ever prove a hypothesis right. Even experiments that work 1,000 times might fail on the 1,001st time. So while we can prove a hypothesis wrong, we can never prove it correct. So what use is it then? Well, first, it does give us provisional knowledge. So if we have an experiment and we've confirmed our hypothesis, then we can provisionally say that our hypothesis might be true and it has not been proven false. Second, if we can think up ways that we could prove a theory to be wrong and we rule out those alternatives, it strengthens our belief in the validity of the theory that we are looking at. A theory is just a hypothesis that has been confirmed via experimentation and not yet falsified. Third, when experiments can be done by different people with different backgrounds and they have the same results, it's more likely the theory is actually true. Now again, that doesn't prove it's true, but if a lot of people from a lot of different backgrounds using a lot of different methods can come up with the same answers, that's a pretty good indication that you're onto something. And that's not to mention the fact that if a theory survives many experiments, even if it is ultimately proven to be incorrect, the fact that it succeeded so much indicates there is probably some facet to the theory that is true, even if not all of it is. For example, Newtonian physics is still good enough to get us to the moon, even though it cannot handle extremely large mass or velocities that approach the speed of light. So just because it fails ultimately doesn't mean that it's useless. And there are many other theories that, while they do ultimately fail, the fact that they did exist and the fact that they were confirmed for such a long time gives us a reason to think maybe there's something in there that, while not quite 100% accurate, is accurate to some extent. But let's step back a moment. As I said, I like to dig into things. I don't want to just present the scientific method as is. There's a more fundamental question that must be asked here. How do we know anything? This gets us to the topic of epistemology. Epistemology is the philosophical term describing how do we know what we know. The scientific method is an epistemological method. There are other epistemological methods available to use. Some are strong, many are weak, but there are more than just the scientific method available. Some strong epistemological methods include the laws of logic and the laws of mathematics, whereas some weak epistemological methods include they told me so, and it feels like it should be this way. And now for something completely different. Suppose that there are two different objects in the world, floorbows and non-bows. Floorbows and non-bows are virtually indistinguishable by empirical means. And suppose I now tell you I have created a machine that can differentiate between a floor bow and a non-bow. The machine works. I drop an object into it. It whirs and beeps and says, this is a non-bow. I drop another object into the machine. It whirs and beeps and says, this is a floor bow. The machine works. Or does it? See, the question is, how do we know that the machine is working? The only way to tell if the machine is working correctly is if we already know what a floor bow and a non-bow is. If we already know, then we can test if the machine is giving us correct information. But if we already know, then we do not need the machine to tell us. And what is the point of this random bunny trail that I just went down? Well, fundamentally, this is where we end up with all claims about how we know what is true or not. The scientific method works exactly like that machine in the analogy works. It gives us the results we already know. If it gave results we didn't think were possible, we wouldn't accept it as valid. And that is a problem. See, the scientific method is an epistemological method, not a complete philosophy. Philosophies must include at least three things: a metaphysics, which is what is real, an epistemology, how do we know, and morality or ethics, which is what should we do about what we know and what is real. Many people also include politics and aesthetics, but I personally think those fit under the above criteria already. But again, that's an aside. The three important parts are metaphysics, epistemology, and morality. And the scientific method is only an epistemology. It is not all three. So, the scientific method isn't a philosophy. Because the scientific method isn't a philosophy, but it is solely an epistemological method, it can work within many different competing philosophies. A metaphysical view that the universe is created solely of matter and energy, and that's all that exists, is the usual belief of many scientists. They're materialists or naturalists, and they say that only matter and energy exist. They use the scientific method. But you can still use the scientific method as an epistemological tool if you believe in the supernatural or in immaterial existence. You don't even necessarily have to believe in God, but many people who do believe in God still use the scientific method. That's not a contradiction because, as I said, the scientific method is not a philosophy. It is simply an epistemological method. So the scientific method does not select for any particular metaphysic, nor is it even able to do so if it wanted to. And more importantly, it is not the only way that we can know something. There is more truth than the scientific method reveals. One has to presuppose the scientific method is correct in order to use the scientific method. You cannot test the scientific method by using the scientific method. It doesn't work. You can't observe it. You can't conduct experiments on it. You can't modify it. You can't do anything with that because it simply is what you're already doing as the method. If you were using it to test it, you've already been using it. Secondly, logical and mathematical deductions reveal things that we say are true, yet without us being able to prove them using the scientific method. You can't prove the laws of logic using the scientific method. The scientific method actually presupposes logic is valid, not the other way around. But again, we cannot prove that it is valid because the scientific method can only falsify. It can't even prove anything correct. And that's the same thing that's true with logic. Logic cannot prove logic either, for logic is built on axioms that are assumed to be correct. If we try to prove logic using logic, it would actually be a logical fallacy. We'd be using circular reasoning. We're assuming logic in order to prove logic, but that is something we just assume to be true. But is that really a problem? No, it's not. It's not actually a problem. It is a fun thing to think about, but is it a problem? No. We just need to remember the limits of what the scientific method tells us. We also need to accept that not all things that are true can be proven. Ironically, that's something that Gödel's incompleteness theorem actually proved. We've proved that not all things that are true can be proven. So about incompleteness. Suppose T is a set of all truthful statements, and it contains no false statements. Let A be the proposition A is not provable in T. If A is true, then A is a truthful statement not contained in T, because it's not provable in T. But if A is false, then A is provable in T. That would mean that a false statement is provable in T. But we've said that T is a set of all truthful statements with no false statements. So the conclusion is, any sufficiently robust method of measuring truth cannot contain every true statement, or if it does, it must contain statements that are false as well. And there is no way to tell the difference using that system. So a system is either incomplete or incorrect, or possibly both. But is this just a trick of language? Isn't that just a paradox, like the liar's paradox? I'm lying. Is that true or false? Well, no, because Gödel actually proved it using mathematics, not linguistics. It is not possible to have a complete system of mathematics, logic, or knowledge as a whole. But it's the strength that's the weakness here. This only happens when a system is strong enough for the paradoxes to come about, which means that while we will always be stuck with these paradoxes, the robustness of everything else can give us confidence in the rest of the system. In other words, no, we cannot prove everything, and we know that there are things that we can't prove which are true, but that doesn't mean we can't prove anything. We definitely can prove some things. So, with all that in mind, I hope you guys have a wonderful day. Peace out.